Last section for chapter 1 is I want to look at 1.6 inverse functions. So let's just kind of jump in and see what we're defining here. When we're talking about inverse functions, we're going to be picking up a new notation, and this is going to be f with a small little exponent of a -1 of x. Now, this does not mean we are raising it to the power of -1. It's just a notation thing. And when you see that notation, because in some of the assignments it may just say that notation with no other words, this means f inverse of x. And so this is not the same as reciprocal. So you want to make sure you understand those notations, similar to what we were doing in earlier sections of composition. You kind of got to know what it's asking for. Now, when we're asking for the inverse of x, what it means is that we are going to take, say, f of a equal to b, then f inverse of b is going to be equal to a. So what we're going to be doing is, in a general sense, we are going to be switching our domain and range. And you may remember some of these inverses from previous math courses. At a very simple sense, we would say if f of 2 is equal to 4, then f inverse of 4, going backwards, would be equal to 2. Now, that's a very simple thing that we're saying here, because we are only inverting or using the inverse of one object, a 2 to a 4, and then that inverse would be 4 back to 2. But when we're looking at inverses, we're not going to just be looking at one piece of data. We're going to be looking at a whole set of data, a whole graph of data, a whole equation or function reflective of information. And so it'll make more sense if we go ahead and move forward with our graphs and our equations. When you're looking at a graph of an inverse, there's something really special about it, and it's the fact that it will be a reflection across the line y equals x. Now, we've already looked at symmetry with origin symmetry and symmetry on the x or y axis. This is a reflection, not just over one of the axes, but a reflection over y equals x, a function. And so it's really kind of interesting how this graph would look. And this means that the function must be 1 to 1, going all the way back to the beginning of this unit. Remember, if it's a function, it means your x's don't repeat. If it's 1 to 1, your y's can't repeat. So you might have to restrict it in order to have an inverse. Because if we're exchanging, if we're exchanging those x's and y's and switching our domains and ranges, we want to make sure that there's nothing repeating on either side of it. And so if you look at this example here of f of x equal to x squared, you can, let's go ahead and graph it. That would look something like this. Now, we just said that if we needed an inverse, that it would have to be reflection over y equals x. Here's y equals x. Again, those parent functions are coming in handy. So if I were to reflect that over, it would look something like this. Now, here's the problem. When I reflect it over, and if I were to do my vertical line test, this would not be a function. It would fail the vertical line test. So what we would need to do is we would need to restrict f of x so that when it's reflected, it still remains a function. That's where that 1 to 1 comes into play. So let's just kind of make some notes here and say, notice that a parabola is not 1 to 1. And we can see that because we have y's repeating, it wouldn't pass that horizontal line test. So we're going to make a note. We can restrict the domain. If we restrict the domain of f of x, our blue function over there, to quote unquote make it 1 to 1, then we can create that inverse. So what's going to happen is we're going to kind of erase here. We're going to restrict that and get rid of this part over here so that when it reflects, we only have this part here. And then you can see that that blue and pink are both functions and one-to-one. And so when they're reflecting, there's no issue there. Then the last thing that we're going to do with inverses is we're going to create some inverse functions. And you're probably going to recall this from previous math courses. And so here's your steps for finding inverses. We looked at like what's kind of going on with them graphically, kind of what's neat about the way they look and that reflection. So now let's create them. So number one, we have that we are going to replace f of x with y. Just a notation thing. Number two, you're going to switch x and y. Meaning in that equation, switch them out. Wherever x is, write y. Wherever y is, write x. Number three, solve for y, that new y that you have. Number four, replace y with f inverse of x. So again, notation. And then number five, you want to restrict the domain if necessary. And all this is going to backtrack to those parent functions and understanding what's going on with those domains and those functions. So let's look at this next example and see if we can kind of follow through with these steps. And so I'm going to kind of leave the steps up here at the top of the screen as we work through this in the bottom. Find the inverse of f of x equals the square root of x plus 3. So step number one, I want to replace f of x with y. So I'm going to say y equals the square root of x plus 3. Then number two, it says switch x and y. So I'm now going to say x equals the square root of y plus 3. Step three, solve for the new y. So I'm going to get this y completely by itself. So I'm going to subtract 3. Make sure you follow order of operations. So this gives me x minus 3 equal to the square root of y. And then in order to get that y completely by itself, you would have to square both sides. So it does matter order of operation here. So that would give me x minus 3 squared equal to y. Step 4 says replace y with f inverse of x. So f inverse of x is equal to x minus 3 squared. And then step number 5, restrict the domain if necessary. Well, since we know that x is going to be positive underneath our original with our square root, let's move up and go to the graph associated with this, because I think our explanation is going to be a better explanation if we have that graph to go with it. And so again, go back to your parent functions and your transformations that we picked up recently. The square root of x plus 3 is going to be here. So it's going to start, it's going to be moved up. If we know that this is reflected over that line y equals x, we know that it would look something like this. Now we know, based off what we just got with that equation, that that was a quadratic. So what's happening is we want to omit this left side. We only want to start at this positive 3. And so we're going to restrict that domain for step 5 and say that x has to be greater than or equal to positive 3. And it's going to go back into knowing your parent functions and your transformations and what's going on with those. Let's jump into the next one. The next one gets a little bit hairy in the creation of that inverse. And so this is going to be more of what you're kind of seeing moving forward. And this will kind of end up our lecture for the inverses here. Find the inverse of f of x. And so I want to follow those steps just like we did before. So step number 1. Y is equal to, so I'm going to replace f of x with y, 5 minus x over 3x plus 2. Step 2, I'm going to switch x and y. X is equal to 5 minus y over 3y plus 2. Now, when you're working these for me on the exams, you always have to show as much scratch work as possible. So you magically don't just need an answer, but you also don't have to number it out like I'm doing. I just want to make sure I'm reflecting back to the steps we just took in the notes, because it's only our second example with it. Next thing I need to do for step 3 is to solve for that new y. Now we have y in 2 different places. The first thing that's really going to kind of stress me out is the fact that I have this fraction. So I'm going to multiply both sides by 3y plus 2. So that'll cancel that, and I'm left with 3y, step 3, 3y plus 2 times x equal to 5 minus y. So at least I got the fraction gone. I'm going to get rid of these parentheses by distributing. That gives me 3yx plus 2x equal to 5 minus y. And the reason I want to do all of that is my goal is to get this new y by itself. So you can see I have a y term here and I have a y term here. Getting everything distributed out gives me a way to move these individual y terms together. And so I am going to get all my y's to the left and everything that doesn't have a y to the right. And so I'm going to say minus 2x on both sides. And I am going to do plus y on both sides. So it gives me 3yx plus y equal to 5 minus 2x. Now that I have both of these y terms on the same side, I can factor out by GCF. So that will give me y 3x plus 1 equal to 5 minus 2x. Now I can get that y by itself, so divide both sides by 3x plus 1. And so then that gives me, I'm going to go ahead and change it back to my notation. Step 4, f inverse equal to 5 minus 2x over 3x plus 1. Now I'm going to tell you, when you're working in the homework and you're working in that exam, it shouldn't be a matter of you just stare at it for a really long time and start moving things around. I want to see each step worked out, because if you don't show your work in your exams, you will not receive full credit. So make sure you work through all your steps in the homework as though you're practicing for the exam. So when it comes to exam, I can give you as many points possible on each question. So I hope this helps and kind of recalls some of that information for an inverses and adds to it from previous knowledge. But as always, reach out to me if you need additional assistance.